Now we're going to take what we learned about special triangles and about Sohcahtoa, the trig ratios of right triangles, and we're going to put them together. So first of all, we're going to recall how to label the special triangles. You should be able to do this without referring to your notes, so definitely practice this. This is a 30, 60, 90 triangle, but we're going to specifically be looking at the 30-degree angle and the sides in relationship to 30 here. Opposite the 30 is the smallest side, 1. The hypotenuse is twice as big as the smallest side, it's 2. And opposite the 60 is square root of 3. I'm going to skip over to the right-hand one because this is the same triangle, just turned a different direction. So this is now the 30 over here, so opposite the 30 is 1. The hypotenuse is twice as big as the smallest side because this was originally part of an equilateral triangle that we cut in half, remember? And so this became the 1 right over here. So just reminding you of that, the hypotenuse is twice as big as the smallest side, and then this would be square root of 3 opposite the 60. The 45 is just 1, 1, and then square root of 2 for the hypotenuse. Now we're going to use these ratios to find cosine, sine, and tangent of 30 and 60 and 45 degrees. So looking underneath the 30-degree triangle, we need to remember Sohcahtoa. So when we see the CAH, that reminds me that cosine is found by doing adjacent over hypotenuse. So this is adjacent divided by hypotenuse. Now what's the adjacent side to 30? Well, the adjacent side to 30 is square root of 3, and the opposite side is 1. And then this would be the hypotenuse. So when we say adjacent over hypotenuse here, we're talking about the square root of 3 over 2. Now sine, opposite over hypotenuse, OH, Sohcahtoa. So now we're looking at the sine. So when we look at this triangle, the sine of 30 is going to be 1 over 2, opposite over hypotenuse. Now tangent of theta, that would be the TOA, opposite over adjacent. So opposite is 1, adjacent is square root of 3, so it's 1 over the square root of 3. Now it's usually fine to leave it as 1 over square root of 3, but you'll often find this written in what's called rationalized form. In other words, we get the irrational number or the radical outside of the denominator by multiplying both the numerator and the denominator by the same number, which keeps the fraction having the same value, and we end up with the square root of 3 in the numerator, and square root of 3 times the square root of 3 is 3 in the denominator. So it can be written as 1 over the square root of 3 or the square root of 3 over 3. Now let's move on to 45. Remember, adjacent over hypotenuse for cosine. So when we look at the adjacent side is 1, and the opposite side is also 1. So the hypotenuse then is the square root of 2, so we have 1 over the square root of 2. If we multiply numerator and denominator by square root of 2, then we could also write this as square root of 2 over 2. So 1 over square root of 2 or the square root of 2 over 2. Cosine is opposite over hypotenuse, which is exactly the same thing. Square root of 2 over 2. And tangent is opposite over adjacent, which is 1 over 1, which is just 1. So that's kind of a handy one to remember, that tangent of 45 is 1. So the nice ones to remember, well, I'll come back to the nice ones. Okay, cosine of 60. So remember here, adjacent to 60, opposite. So here's my adjacent side, opposite side. Now I do want to point out that if I were talking about 30 degrees and it was up here in this triangle, the opposite side then would be at the bottom and the adjacent side would be this vertical side. So it depends on the side's relationship to the angle I'm trying to find. I just happen to position all of these angles in what's called standard position, which we're going to talk about, you'll actually talk about in the next video. But don't think that the adjacent side is always the bottom and the opposite side is always the vertical side unless the angle that I am trying to find is in this standard position. Okay, so cosine of 60 now is 1 over 2. Sine of 60 then is and remember that's adjacent over hypotenuse. Cosine is opposite over hypotenuse, which would be square root of 3 over 2. And tangent is opposite over adjacent, which is the square root of 3 over 1, or the square root of 3. So I want you to notice what I think of as the nice ones, because these will be really helpful when we graph. The nice ones to remember are sine of 30 is 1/2, cosine of 60 is 1/2, and tangent of 45 is 1. Those are ones we're going to use a lot when we graph because they're easy to plot. They're just 0.5 and 1. They're nice numbers. So those are good ones to remember. I also want you to notice that sine of 30 and cosine of 60 have the same trig value, and cosine of 30 and sine of 60 have the same trig value. And the reason why and then cosine of 45 and sine of 45 have the same trig value. If the angles are complementary, cosine and sine have the same trig values. So cosine of 30 and sine of 60, same trig value. If I did cosine of 10 and sine of 80, they would have the same trig value. That's what's known as cofunctions, and we'll talk more about that later.